Okay, welcome to our next data journalism in R lab. We're going to be building on everything we've done up to this point in the semester in analyzing opioid data. Today we're going to build specifically on the work we did last week, doing some exploratory visualizations. Today we're going to do some exploratory, we did some bar charts and line charts last week. We're going to learn how to make some maps. When you're working with data that has a geographic component to it. In this case, we have information about zip codes and counties and states in the data set we're using. Mapping it can be a really useful way to identify regional or geographic trends. So that's a bit of what we're going to be doing today. So this lab is the same as almost all previous labs in that you are going to follow along, listen to what I'm talking about. You're going to see the word task at several points, and that usually indicates I want you to write some code. Okay, so you should have downloaded onto your desktop this markdown file for the lab. Have it open, have it moved over to your Git repo, the usual step-by-step process. And the first thing we're going to have you do is load the packages that we're going to be using today. So again, always good practice to load the packages you plan to use up at the top of the document. We're going to be using the tidyverse. We're also going to be using Janitor for some very light data cleaning. We're going to be making extensive use of the Post's Arcos API for pulling down the slice of the DEA's Arcos opioid shipment information database that was released by that news organization. We're also going to be using the Tidy Census package today. We're mostly going to be making use of this for getting geographic data so we can build our maps. We're also going to be using scales, which we used last week to clean up axis labels and legends. We're also going to load two new packages. So most of the mapping we're going to be doing is part of the core ggplot library, which loads when you load the tidyverse. But there are two things that I want us to work with today. So another one is called MapView, and this is for just pulling up some really great kind of quick and dirty interactive maps. And then there's also a package called GG Themes, which is something that, forget who built it, but somebody built it that allows you to sort of add custom styles to a lot of ggplot charts, including making some maps in the same manner, maps and charts in the same manner as some news organizations like The Economist and 538 and a couple other places. Okay, so here's your first task. In a code block below, I want you to load the tidyverse and Janitor and Arcos and Tidy Census and Scales, MapView, and GG Themes. If this is the first time you've worked with any of these packages, you're going to have to install them first using the install packages function. Okay, so again, we're going to be using the Arcos R package, which gives easy access to a lot of the data that the Post and the Charleston Gazette-Mail obtained in suing for access to the Arcos database. There's lots of different functions that slice and dice it in different ways. Just as a reminder, you can pull up access to it here, and there's in the reference there's a link in this document, but it shows you all the different ways you can pull down information. There's data on opioid shipments, but there's also additional information like demographic information for some of the counties. Okay, so again, like usual, the first thing we need to do is store an API key. So this is one that the Post has made available. You're welcome to use this. You can also go get another one here. So I'm just going to run that. And I see my key is stored up here in the environment window. Okay, we're going to load two tables here. So our goal today is going to be to try and build several maps that will help us explore which counties and states received more pills than other parts of the country adjusted for population. We're going to try and see if we can pick out any sort of regional trends that might be interesting. that maybe we haven't been able to see before we actually visualize this information geographically. So in order to do that, we're going to need to get two things. We're going to need to get pill shipment information, and we're going to need to get population information for both states and counties. So we're going to use that to calculate the pills per person statistic that we've worked with so often. So the Arcos API already has a table that has total pills shipped for each county in each state for each year between 2006 and 2012. So we're going to pull that down. We're going to clean and standardize the column headers with the clean names function. And as always, we're going to pass our API key to the function. Otherwise, it won't return data. So I'm going to make a new object called Arcos County Pills Per Year. I'm going to run that. Shows up here. I've got 21,597 rows of 6 variables. Just look at that briefly. So we've got, for most counties, it's going to be 1 record per year from 6 to 12, although there are some that only have 2 to 3 years because there weren't shipments in certain years. Information about total pills, that's dosage unit, and the county FIPS code. Okay. So we also need to get population data. So we could get this from the census. We're going to use actually the Arcos API, the post released, has this really nice county population table already built in, where we can just pull the county population, which is also from census data, each year between 2006 and 12. So I'm going to run that, and I get a table here of 22,001 records, 1 record per county with population estimate for 2006, and then let's see if I can sort by county. So here's the population estimate for Abbeville, South Carolina in 06, 07, 08, 9, 10, 11, and 12. Okay, so just something I want to go back to because this is really important. We're going to do a join of these tables together in order to be able to calculate the pills per person statistic that we need. And I just want to reinforce this. So we have an inconsistent number of records in these two tables. So the pills table has 21,597 and the population has 22,001. So why is this? Well, this is because there are some counties in the population table that aren't in the pills table, and then vice versa is also true. We could do left joins and right joins, and try and see what's missing. We did go over this a couple weeks ago. I showed some of you this sort of in class. This may be a new thing to some of you. It's called an anti-join, and it allows you to see which records are in one table but not in another table. So I'm creating this new object called not in pills. So I'm taking the population table that we just downloaded from the Arcos API, and I'm doing an anti-join. So when I run that, this not in pills table, there's 999 records. These are all counties and year combinations, a combination of a county and a year for which there's a population, but we don't have a match in the pills table. And then I also did it the other way. I created a table called not in population. And here we can see there are 595 records that are in our pills table, some combination of a county and a year, that are not in our population table. And for the most part, these are things like Puerto Rico, or there's some Virgin Islands in here, some other examples of U.S. Commonwealth type places. There's also some other things in there. So it's always good to know when you're doing joins, sort of what's being left out, what's being left in. Sometimes it's fine. It's always better to know so you can make a sound editorial decision that's not going to lead you to wrong information. So here's your first task. I want you to examine the not in population table, and just in this little code block below here, just write some text and start it with a comment explaining why you might see records in the pills table that aren't in the population table, and how this might cause you problems in the future. So there's the Puerto Rico, Virgin Islands example. That one's pretty easy to get around. We're not really going to be mapping information about Puerto Rico, or there is not that information in the pills database. But there are some other problems, maybe some that you've seen before, and I just want you to see if you can, tell me why that might be happening. Okay, so now we've got, again, the information in the pills table, which has the number of pills shipped by county by year for each county in the U.S., or for most counties in the U.S. And then in a separate table, we've got the information on population by county by year. So we need to join them together, and we're going to join them on both county FIPS and year, because remember, each record in each table is not just a county, right? It's a county in a particular year. So we're going to have to join on county and year. So in my join down here, I've got county FIPS and year. I'm also going to throw in Byer County and Byer State. And the reason for that is that both of those things exist in both sides. There's a Byer County and a Byer State on both sides, and they're the same. So even though there's no pure exact reason I need to do it on that, what I'm trying to avoid here is that weirdness we sometimes get when you join on something that has the same column names, but you're not joining on that, where you get like ByerCounty.x or ByerState.y. So by putting all four of those things in there, I'm just avoiding that problem. If you don't do that, you're going to end up with a ByerCounty.x and a ByerState.x, and then a copy of it, ByerCounty.y and ByerState.y. Okay, so I'm going to run that, get this new table. I did a left join here, starting with the county population. Just for mapping purposes, I just wanted to have a pretty consistent set of all the counties in the U.S., even if that information happened to be missing in the pills shipment. So we get 22,001 records of 12 variables. Got Byer County and State. Got this FIPS code, which is information, a specific ID for each county. That will be important later. We've got the population and the count. This is the number of shipments. This is the total pills. And this is the total population. Okay. I also want to clean up our data set just a bit more because we are going to be mapping by state below. I need to do something in order to make sure that when we end up joining it with the files we'll need with the geographic information, the actual shapes, say, of the states, that everything is, that there's a common field there. So I'm going to do a little string function here to strip out the first two letters, or first two characters from the county FIPS code, and store them as a new column called state FIPS. So again, here is our county FIPS code, right? So Alabama, it's made up of 01 and 001. This is Autauga, Alabama. And the first part of this FIPS code is the state, right? It's the reason that Baldwin is 01003. And then the last three digits are the specific county. So all of the Alabama ones start with 1, all of the Alaska ones start with 2. So I'm pretty sure Alaska starts with 2. Let's see. Yeah, Alaska starts with 2. Okay, so this is a new thing for us, string sub, and it basically says take the thing that's in the county FIPS column and take all of the characters starting at position number 1, ending at position number 2. So the first two characters, put them in state FIPS. And then I'm just going to select only the columns that I need. So here is Pill's population now. And I've got this state FIPS, right? It took county FIPS, took off the first 2 characters. And if we scroll down to Alaska, you can see it took off the first 2 characters, O2 and O2. And again, we're going to need that because, well, we'll go over it when we get down below. We just need to make sure that it joins properly, and so that's why I'm doing that. Creating a incontrovertible, not easy to miss FIPS code for each state. Okay, so now we have a nice table we can use to build our maps, but before we do that, we're going to need to get some shape files. Shape files are essentially text files, very typically large, complicated text files that contain collections of latitude and longitude coordinates, either organized as like lines or polygons, some sort of, like a rectangle or an oval, that we can use to draw the map. So without these, our program wouldn't really know how to plot the information that we've got, like to map, and by map I mean like align, say the pills per year with the pills per person per year with like a corresponding shape of a state. So that's what a shapefile do, right? It contains information that says, connect these points in such a way that this looks like the state of Maryland, or this looks like the United States, or it looks like Anne Arundel County in Maryland. Okay, so there are lots of places to get shapefiles for all sorts of geographies. If you just go out there and search .shp, that's one format you'll often see. KML is another very popular format. The census, for a lot of what we'll be working with, maintains some really great shapefile polygons. So let me just pull that up, and they call it Tiger, and I'm not sure why it's called Tiger exactly, but it's called Tiger. And there's all kinds of like really detailed information, like you can pull down census tracts or congressional districts or school districts or zip codes. You can get these from the census directly, download them, and upload them. We in this class have been making use of the Tidy Census package that allows you to search for and then pull down census data on a variety of topics: demographics, race, income, age, all sorts of things. The Tidy Census package also allows you to pull down these the geo-located or geo-shape files that will allow us to do mapping. Everything from states to the country to counties to cities, whatever we want to use. So we're going to use the Tidy Census package. Just as a reminder, just like with the Arcos API, you need to have a password or a key that's allowed you to access it. Mine's in here. You can use mine. Even better would be to sign up for your own. So go ahead and click this link, and you can sign up for your own API key, and you just swap it out here. So I'm going to run that. And then I've commented this out, but this is just a reminder. This function is part of the Tidy Census package, load variables. And what this says is load all of the potential bits of information you can pull out from the census. So this pulls out all the things that were available for 2017. This is called the ACS-5. ACS, American Community Survey, is a survey product the census does, and this is a 5-year average of what they've collected leading up to 2017. So if I run that, we can see it pops up this new table here, ACS variables, and you can see all of the different things that are available. The total number of men under 5 years by age for whatever individual population you're pulling. I can turn on filters. I can do like median household income, and there's a bunch of different variables there. This variable number, right, is the thing that you need to feed into the Tidy Census functions in order to get back that specific bit of information. Okay, so for the purposes of this, we're going to pull down some information. And when we pull down that information, we're also going to pull down the geometry for the geographic units we define. So I'm going to have us pull down 4 different sets of data here. The first one, we're going to pull in sort of geometry or shape files for every county in the U.S., and then we're also going to pull it down for every state in the U.S. So this is each county in each state, and this is each state. So the function here, right, is get underscore ACS. The geography, I'm saying get the information at the level of the county. The variable that I'm feeding it is B01001 underscore 001. If we go back to this table, we'll see this is just an unweighted sample count of the population. I just chose that because it doesn't matter what we're pulling here. What we really want is the geometry, and then we're going to join it to the pills table we created. Okay, and then for state geodata, it's the same thing, but I'm changing the geography to state. Okay, so I'm going to run those, and then I'm going to pull up the state one, and we're going to look at it. Just a warning to you. If you are working on a slow machine, as I know many of you are, I would suggest not viewing this. And the reason I would suggest not viewing it is that the information that is contained in the geometry column is so dense that it can really slow your machine down. So my machine is fast. I would suggest not doing this if you're worried about it. Just watch the video and you'll see. So the last column here has geometry information in it, and you can see on my machine it's really dragging. So let's just give it a second here. Okay, so these weird sort of black symbols, there's a lot of information just layered over top of it. If I hover over it, you can maybe start to get a sense of it. It's a very long nested list of lists that contains things like negative 166.57. These are all individual points. It's just you draw a bunch of dots and then you connect the dots. Those dots form a polygon that is ultimately in the shape of Alaska or the shape of Arizona or Alabama. Okay, so again, I wouldn't recommend viewing it. The other thing we're going to do is I want to pull down just a slightly different version of this. And let me just close this because it's really choking the data here. Okay, so the other thing I want to pull down is a slightly different version of the geometry, and it's called shifted, or at least that's how it's referred to in the Tidy Census package. It's going to help us make better maps. The only thing that's different about this versus the maps that or the shape files I just had you pull down above is that instead of putting Hawaii and Alaska in the spots where they'd usually be, you know, Hawaii way out in the Pacific Ocean, Alaska pretty far north. Alaska is also huge, and it makes the map unnecessarily large and hard to see details. So what this does is it basically takes Alaska and Hawaii, makes Hawaii slightly bigger than it would otherwise be, Alaska much smaller than it would otherwise be, and positions them like really close to the contiguous 48 states. I'll show you an example of what this means in a minute. I guarantee you've seen a map like this, but it just makes it easier to view. So we're going to pull it. The only thing that's different above is this property here, shift geo equals true. Okay, so that is pulling down. Also, you'll note it gave you this return here. Please note Alaska and Hawaii are being shifted and are not to scale. I'll show you a quick example of generally what that looks like right now. See this map here, this little interactive map? We're going to make this kind of later on, but it basically takes Alaska and Hawaii and sticks it kind of right here. Okay, So, I don't recommend viewing these files. We also can't use glimpse or summary for some reason. I'm not sure exactly why. Normally we would do that to like look at a data frame. We can use this bit of code. I'm printing the head or the top 6 rows of, this is the state geodata shifted shapefile I just pulled down. So when we run that, you can kind of see the geometry out here. So even if you can't view it, you could always look at things here. And I think actually we could do, let's see if that works, $ geometry. Yeah, it doesn't really help us that much better. It just gives you a sense of what some of the coordinates are. Okay, so to start, we're going to build a simple map, and we're just going to build it from the shape files that I downloaded. So before we go about joining our pills data to the geometries we just pulled down from the Tidy Census thing, I want to make a simple map. We're just going to do it from the information in the shape files. In this case, that thing we pulled down, the little like bit of info that came down with the shapefile, was the unweighted population. And we're just doing this so you can see how ggplot2, the visualizing package that we're using, treats geospatial data. So we just need 3 lines of code. So this is this here. We need the name of the data frame that we're doing this to. So it's called state geodata shifted. Then we're throwing in something that hopefully looks familiar from the last lab. Just a line saying ggplot. And we're saying fill it, like make the colors that we're filling in the shapes with equal to estimate. So estimate here was in our table. And all this is it's what the Tidy Census package, when you ask for a variable, it's what it calls it. So in this case, estimate is the unweighted population. And then we're adding one new bit of code here, which is geom_sf or geom_shapefile. And it basically says, look for a geometry column and then make a map. So when we run that, this is what we get. We get our map, and the darker colors are lower. So these are smaller population states. The darker blue, or the lighter blue, are lighter population states. Just a note, if you get the weird scientific notation, just run this option scipen equals 999. It'll turn it off. Okay, so as we learned last week, right, we can start from these very basic, let's just produce a map, and then we can add new pieces to our function to style it further, to make it look like we want it to look like. Okay, so I'd say here's a good place to start. The information that was printed here, the axis has the like latitude and longitude coordinates, which who cares? Really all we want is just this map. Oh, and you can really see on here this shifted thing, you know, Alaska and Hawaii are down here. Just kind of easier to see them. Otherwise they'd be way up here or way down here, and this map of the US would be tiny. Okay, so in order to get rid of those, clean this up a bit, I'm just going to add one line. So this is the same as above, and I just add a plus sign. And then I'm adding this theme_map. And all that does is, and I'm pretty sure this is from the GG themes package that we loaded. It's like a extra bit of code that somebody built on top of the ggplot library. If I run that, just by default, does a couple things, right? It gets rid of the sort of gray background here, gets rid of the axis labels because those are kind of pointless, and then it moves the legend kind of over to the left here. So a little bit tighter, looks pretty nice. All right, so we can keep making customizations. I don't really love these like thick gray borders around each state. So I'm just going to set the line width to 0. So inside of the geom_sf function, I'm adding LWD equals 0. So when I run that, get a new map. Got some nice thin lines here. Okay. All right, so we can keep going. So I'm going to clean up the legend title here. Right now it says estimate. That doesn't really help anybody. What we're really looking at here is population. So I'm adding a new bit of stuff here, a labs function, and filling it with the word population. I'm also going to add some commas to this. This is really hard to read here. Is this 300 million? Is it 30 million? Is it 3 million? Who knows? So I'm adding this scale fill continuous, labels equals comma. And then I want to move the legend to the right, so I'm changing legend.position to right, and I'm adding it inside of this theme function. Okay, so got a new title, got some commas here, move the legend over. We saw this in the last lab. I also want to give it a title and a subtitle and a source. So I'm adding some additional information to my labs function. I'm adding a title, a subtitle, and a caption. Okay. All right, this looks pretty good. The last thing I want to do is, I don't really love this. It's pretty good, but I want to give it a cooler color scheme. So ggplot2 has a bunch of really great like color schemes kind of built in. So I'm going to pull this over. We're just scratching the surface really of all the things you can do inside of ggplot. But it has this great color scale called Viridis with a bunch of different options. Maybe you might like these and want to play around with them. Supposedly this is really good for be perceived for people with color blindness. So if you happen to be colorblind, this might be useful for you. Certainly not a bad idea to use them if you're going to be ever showing these to anybody else. All right, so I'm going to give it kind of a cooler color scheme. So I'm going to replace scale fill continuous labels equals comma with scale fill Viridis C. And the option I'm going to choose here is called magma. And we get this like pretty sweet purple to yellow one. There's also other ones you could play around with. There's plasma. I'm not sure what makes that plasma-y, but kind of hard to look at. There's also Cividis. That one's pretty cool. Kind of Cal Berkeley colors. Let's go ahead and leave it at magma. Okay, so again, we really are just scratching the surface of ggplot and ggplot2. There's so many things you can do with it, different chart types. We can add additional layers to this. But the thing I want you to take away from this is that there's pretty much a way of doing anything you want to do to style a map, and you should look at the documentation to get a sense of that. And really, generally, what we're talking about doing is just adding an extra line to our function or changing some of the properties within one of the lines in our function. Okay. There are also a lot of other mapping libraries we can use. So before we move on, I want to show you how we can create a very simple interactive map that we can use to further explore the data. This library is called MapView. I'm not going to show a ton of the options that are possible. I just want to show you how to make a real basic one. So after we've loaded the MapView package, which we did again, the function we want to use is called MapView. And there's a couple different arguments we feed into it. The name of the data frame, so state geodata shifted, that's the same one as here. zcall is the name of the thing we want to fill in the polygons on our map. In this case, it's estimate, which was also the population data. And then legend equals true. Do we want a legend or not? So when I hit play, pops up this pretty sweet map. I can zoom in case I'm curious about stuff. If I hover, there's like specific, population data. If I click on it, I can look at every single value in all the tables. It's just a really great way to explore the data. At the state level, maybe not all that useful, but you are going to make one of these for at the county level below, and it really can come in handy when you're trying to explore information. You can also change the base map. Some other cool stuff there. Topo, yeah. Okay. Okay, so now our goal is to look for. We've learned some basic things about how to build a map, both a static map and an interactive map. So now our goal is to look for regional trends, they're at the state level or the county level, in opioid shipment rates. We're going to start by building a state map that shows pills per person shipped per year to each state. Above, we created a table of pills and population that joined together all of the information we had about the pill shipment by county by year with the table of population by county by year. So first thing we're going to do is we're going to get our data into shape before we think about visualizing it. So we're going to make a state table looking at state level totals in 2009. So creating a new object called pills population state 2009. We're taking our pills population table, we're filtering out just the 2009 data, then we're grouping by the state FIPS code that we created. This is a 2-digit code for each state, and also adding in the buyer state name. Then we're going to create some totals. So for each state, we're adding up all the values for all the counties in 2009, creating a sum of dosage unit. I'm also adding this little bit of code that may be new, na.rm, removing NAs. If we don't do that, it causes problems. It prevents it from totaling properly. And then total population. That's a new column where we're adding up the population of each county in 2009 to get the state population. Then I'm calculating the statistic we want to visualize, which is the pills per person, the total pills divided by total population. One thing to note here is that we're adding up all of the county values to get the total for each state. In our original pills shipment table, there were some shipments that were assigned to states but didn't have a corresponding county. And when we did the join, we made a decision to ignore those. So the totals may be slightly off, but they'll generally be pretty close. Okay, so I'm going to run that. So now we have this new table called pills population state 2009. Got our state FIPS, buyer state, total pills, total population, pills per person. Highest is in West Virginia, and so on down. Okay, so now we're going to join it to our shapefile data for our states using the GeoID from our shapefile. So remember, we're using this thing called state geodata shifted. This is the state geodata file where Alaska and Hawaii are not where you would normally expect them to be, to make it easier to see. We're doing an inner join, GeoID and state FIPS. So I'm going to run that. So now we got 51 observations of 10 variables. I'm going to pop this up and view it. Again, if your computer's slow, I wouldn't advise doing this. So now we've got all the information for our state. We've got our pills per person. We've got the geometry attached to it. Okay. So for your first task, what I want you to do is I want you to make an interactive map version of the map that we did above, right? So remember, we used the map view function. So I'm just going to scroll back up. I basically want you to make this map, but instead of showing the population, which is what this map shows, I want you to show pills per person. All right. So the code is going to be similar. You're going to need to change some things, but that's what I want you to do there. Okay. So now we're going to plot out just a very basic version, which is I'm taking the data frame we just made, GeoPills population, setting the thing we want to color each state according to, the pills per person, and geom_sf says draw a map. So when I run this, we get a nice map which shows in lighter blue the pills per person rate, and darker blue, those are higher, and then in darker blue, it's lower. All right. So now, the task that I want you to complete is I want you to stylize the map, and I want you to make it look like the final population map above that we created in the first part of the exercise. So I'm just going to scroll up so you can see which one I'm talking about. So that's this map. Had the nice like title and subtitle and a source. It had a legend. Had this nice magma fill. All right, so I want you to make that, but I want you to do two changes. So the two changes I want you to do are I want you to make it so this legend here is centered down here at the bottom of the graphic instead of at the right. I might try ggplot and searching for legend.position. And then I want you to write up a headline, a subtitle, and a source that are appropriate for the chart that we're using here. So, namely, what's the trend you see? Write it out in as plain a language as you possibly can. Okay, so I'm going to show you how to make one more kind of map, and that's a facet map. So we did this before where we had a collection of a number of bar charts in a single graphic in the last lab. We're going to do the same thing with maps. So let's say the thing we're trying to do is that we want to see how the rate of pills per person changed over time in each state between 2006 and 2012. So I want a single map for each year for 2006 and 12 in which the thing that's colored in the states is the pills per person. All right, so like all these things, right, we got to get our data into shape first. So I'm taking our original pills population file, and I'm saving it as a new object called pills population state, and I'm going to group by the state FIPS code, the buyer state, just like we did above, but this time I'm also going to add year. So what we want is one record for each state for each year. So I'm going to summarize, add up all the pills in all the counties in each year, add them together to get total pills, and then do the same thing for population. Then I'm going to create a new column with my pills per person statistic where I'm dividing total pills by total population. So I'm going to run that, and let's just go ahead and take a look. So now we have 357 observations. So here are one record for Alabama in 06 with the pills per person number, one record for Alabama for 07, for 08, 9, 10, 11, and 12, and then we start over again with Alaska, 6, 7, 8, 9, 10, 11, and 12. Okay. Now we've got the information that we want, the pills per person statistic for each state for each year. Now I want to join it to our file that has the information about the shape of each state and where it's located. That's our state geodata file shifted. Doing an inner join of pills population state, looking for the GeoID column in our state geodata shifted, and matching it to state FIPS in our other one. Okay. So again, I wouldn't advise looking at it if you have a weak computer because it may load really slowly. All right, so now we're going to plot it. So above, right, we created a chart that was a graphic that was like one outline of the entire U.S. There was only one U.S. map, and had a title and a legend. It was that nice magma color. So we're creating exactly the same thing, okay? The only difference is I'm adding this one line, facet wrap, tilde year, comma, n row 2. So what this says is create one chart for each value, or create one map for each value in the year column. So there's a 6, a 7, an 8, a 9, a 10, an 11, and a 12. and then organize those into 2 rows. So in this case, it'd be 4 on top, 3 on the bottom. So when I run this, get one value for 06, for 07, 8, 9, 10, 11, and 12. Pretty clear trend we can pick out here too, by the way. Not just nationally, but also regionally. So here's the task I want you to do here. I want you to copy this code. All right. I want you to paste it in right here. And I want you to modify the title, which I've left blank here in the subtitle, to identify the trends you see. You know, what happened between 06 and 12 that this map tells you? And are there any places that pop out? So that's your task here. Okay. And then last, you have 2 additional tasks, and just complete as many of these as you can. The first is, I want you to, we've done a lot of examination based on state, right? But now I want to look at county trends. So the first is, I want you to make a single interactive map. Remember, we just needed a single line of code when it came to actually making the interactive map that is colored based on the number of pills per person in each county in 2009. So I've already built this, and I'm just going to bring this over. This is ultimately what you're making, right? Each shape is a county, and it's colored according to the number of pills per person in 2009. Okay? So this is what I want you to make. When you click on it, the name of the county pops up and additional information like pills per person. Really cool way to explore the data, right? I also want you to write up kind of what you find, right? Do we see any interesting trends here? You know, one obvious one is this belt in Appalachia, but is there things going on the West Coast? Are there other stories you may have missed from elsewhere? Okay, so that's the first one that you're going to do. The challenge here, right, is going to be getting the data into shape. The one line of code to visualize that, we showed you how to do that above. But getting the data into shape so that you're actually having the pills per person by county is where the challenge comes in here, I think. Okay, and then your last task is, I want you to make a static facet map like we just did here that has one map per year between 06 and 12. But instead of showing the entire United States with each state colored according to the pills per person, what I want you to do is show just Maryland counties colored based on the number of pills per person in each year. So this here is what you're going to be building. Got one Maryland shape for each year between 2006 and 2012. And the pills each county is colored according to each county is colored according to the number of pills per person. Okay, you should see some trends there. So provide a short write-up on what you find, what trends you see. Give me a nice subtitle and title. Again, the code to make that map is going to be really similar to the code you made for this last states one, or with showing the entire country. But there's going to need to be some modifications to just show Maryland, just show counties. And really the challenge here is, how do you create a subset of the data to only show Maryland counties? So think that through. Okay, that is basically the lab. So good luck when you're finished. Save the R Markdown file, knit it to HTML, make sure it compiles correctly, upload it to GitHub, and put your links up on Elms. Okay.